In this lesson, we will take a look at the first rendering option by continuing to use the FSAE steering wheel render file. With the scene settings prepared, we just need to set up our viewpoint to begin to create an in-canvas rendering. I'll start out by looking at some of the default views, such as the home view, then the top view, or perhaps something in between. For the first rendering, we'll use the home view. Under the in-canvas render pull-down, let's first take a look at the options. The in-canvas render tool will start to play or start to generate a rendering live on the screen. There are also options available for capturing the image on the screen. For now, I'll just start in-canvas rendering. In the lower right, you'll see a set of options. This is where you'll set the quality level of the rendering along the bar between excellent, final, or infinite to allow the rendering to generate until you stop it. Beneath the slide bar, you'll see the elapsed time, as well as the number of iterations. An in-canvas rendering will improve the quality displayed on the screen with each iteration. The limits on the bar simply establish how many iterations will be processed. Notice that while rendering is happening, a red square appears over the icon that started the in-canvas rendering. This will allow us to stop the process by selecting it. However, what we want to do right now is to allow a rendered image to develop until we're satisfied with the final product, or to help us understand what the current scene settings do for the developing image. The more iterations that we allow to develop, the higher quality the image will be. The speed that the iterations are developed at can be affected by the materials you use or even the performance of your computer. The fine grain of a carbon fiber material takes a lot of calculations to try to develop the highlights and lowlights of the bump map that simulate a real texture on an otherwise flat model. An important consideration for choosing to do an in-canvas rendering is that all of the calculations are done on your local computer, so the speed of the rendering will be based on your system performance, and if your system is limited, rendering can affect the overall performance of the system. Other rendering options can take advantage of cloud computing and alleviate any strain on the computer. Another important consideration for in-canvas rendering is that unless you change the default, any movement in the position of the model or the zoom factor will start the rendering process over because it would need to recalculate the ray trace of the light based on the new position. Now that the images are getting close to excellent, we'll pause it and select Capture Image. I can choose whether or not I want to use the current document size, which is presently controlled by the 16:9 ratio that we defined in the settings. When we click OK, it will ask us where we want to save the file, what format to save the file in. We can choose between JPEG, PNG, or TIFF. We can also choose to save it to the cloud project or to the local computer. When we click Save, you'll notice the image is not saved to the rendering gallery. The gallery is reserved for cloud renderings. As I mentioned previously, this rendering is done on our machine. If I go to the Data panel and go to the project and refresh, I can see the image is saved to the project. If I double-click the image, it will open it through the web viewer. Now, let's pause the ray tracing and stop the in-canvas render. I can close out of the render workspace without saving because we haven't made any changes to the file other than our view of the model since opening, because all of the scene settings were previously saved.